Welcome back to Lesson 6, Finance and Derivatives. We're going to continue here with the first example. We created the demand function at the end of the first video, so we're now going to use that demand function to create a revenue function. And to create a revenue function, if we just recall here, revenue is equal to x times p of x, and p of x is a demand function. What's a demand function again, Mr. Wills? So there's a demand function from the previous question. Alright, so we've got our p of x function, so our r of x function must be this. X times p of x, this is our p of x function. So I'm just going to expand that out quickly by distributive property. So I expand it out, multiply the x into both, and then I take the derivative. Why do I want the derivative? Because the question asked me for the marginal revenue. So I've got the derivative, and of course I want the marginal revenue at 150 music CDs. So what do I do here? I just plug in 150 into my marginal revenue function, and I get -3. Once I do this, because this is a rate of change, I'm going to do a proper therefore statement. So here's my therefore statement. When 150 CDs are sold per week, the revenue is decreasing. So again here, decreasing. Why decreasing? Because I have a negative marginal revenue at a rate of $3 per additional CD. So I've got a nice therefore statement for my problem. Let's go to the next problem. Here we go. The cost of producing X music CDs can be modeled by the function C of X is equal to that function. Determine the marginal cost of producing 150 CDs. So again, what I want here, because I say marginal cost, I want to find the derivative of C, and this will be C prime at X. So I'm going to take the derivative here using the power rule, so I'm going to have -0.006x plus 4.2. I'm going to plug in my 150 here. When I plug the 150 into there, I'm going to get 3.3. What does this mean, Mr. Wills? Well, I'm glad you asked. We do a nice therefore statement. Therefore, I'll write it out. Oops, therefore, when producing $150 CDs per week, oops, the marginal cost is $3.30 per CD. There we go. So our cost is increasing, which is not a good thing because that means that we are beyond the optimum value. Let's continue. Here's the next one. Determine the actual cost of producing 150 first CD. So to do this, to find the cost of producing 150 first CD, what we're going to do is we're going to do the cost of 151, but of course that's the cost of producing first, second, third, fourth, fifth, all the way up to 151, but we're going to take away the cost of producing the first 150. Alright, so I've got this equation here, so I'm going to plug it into my function. So it's not marginal, so I'm going to actually use the C of X function, of course, here. So if I put in my calculator, which I can assume all of you can do that, we are going to get the value of 3.297. What does this mean? Well, if you notice here, if I go back a slide here, this one costs $3.30. This one, if I plug it in here, costs me this much money. Very, very similar. Why, Mr. Wills? Well, the actual cost of producing 150 first CD is approximately $3.30, if we notice a similarity between the marginal cost of the 150th CD, for large values of x, the marginal cost for producing x items is approximately equal to the cost of producing one more item, or the x plus 1 item. These two things, especially as x gets really, really big, these two values will become the same. So for a large value of x, basically c prime of x will be equal to c of x plus 1 minus c of x. And this will always be the case as, again, x gets large, as x goes to a little bit of limits here, as x goes to infinity. So the larger x is, the closer these two values will be. All right, a couple more here. Let's talk about this. Determine the profit and marginal profit for selling 150 CDs. So again, if we recall here, profit is equal to P of x equals R of x minus C of x. So if I do this here, I'm going to have R of x. R of x is equal to 42x minus 0.15 x squared, as I saw before, minus negative 0.003 x squared plus 4.2x plus 3,000. So I get this. I'm going to simplify it by adding like terms. When I simplify by adding like terms, I'm going to have negative 0.147 x squared plus 37.8 x minus 3,000. So this right here, this is my P of x function. And it says it wants the profit and the marginal profit for 150. So the first one I'm going to find is P of 150. So I'm just going to plug in 150 in all my x values here. And here I get negative 637.50. I will also do it for P prime because it wants the marginal. Marginal means take that derivative, find the instantaneous rate of change here. So here if I do this, before I do that, whoops, I need to do this. I need to actually find what P prime of is, P prime of x. P prime of x will be, if I take the derivative here, it will be negative 0.294x, again bringing that down using the power law, plus 37.8, and then I can plug in my 150. When I do that, I get negative 6.30. All right. So what does this mean? This means when selling 150 CDs per week, the total profit was negative $637.5, which means, of course, they were in the red. Not a good thing. And the marginal profit was decreasing, by $6.30 per CD sold and produced. So this means two things. One, they're in the red, they're losing money, but also because their profit is decreasing, that must mean they've gone beyond the maximum profit, and now they're starting to, their marginal profit is losing. They're losing money per CD, which is never a good thing. All right, let's go to the last one. Here we go. Last one. Solve for p prime at x. Interpret this value in the situation. So here, my p of x function is again, or my p prime at x, sorry, is negative 0.294x plus 37.8. Oops. So set this equal to 0. So I get negative 0.294x plus 37.8. I solve for x here, and when I solve for x, I get x is equal to approximately 129. We have to keep it as a whole number because these are products. This is round to whole number. What does that mean, Mr. Wills? That means the max profit occurs when 129 CDs are sold. And there we go. Okay. So that's that. Let's look at the homework briefly. Here's the homework. Question 1 is good, question 2 is good, and question 3 is good, or sorry, question 5. I suggest question 5 for sure. Why 5, Mr. Wells? Because it wants you to create the demand function. And this is always a nice test question. So it wants you to create the demand function right there. Question 2. Question 8 looks good as well. And then we've got 15. Do not worry about 15 right now because we can't do it because we need the quotient rule to take this derivative right now. So 15 I wouldn't worry about. 11 is good. And 19 is good as well. But don't worry about 15 for now. We'll come back to 15 when we can do the quotient rule, which will have to happen on in a couple days.